So here are the notes for 7.7 day 2. So this is actually where we're going to once again write equations, but we're going to write power equations or power functions this time. Now this is once again using either 2 points or the regression feature on the graphing calculator. So example 1, it says write the equation of the function y equals a times x to the b. What this is actually called is our power function. It's a power function because notice what changed here. That our x is no longer in the exponent spot, but now it's the base and our b value is the exponent. So that's why this is a little bit different than the 7.7 day 1 notes where you worked with exponential functions. Okay, so here we're going to write the equation of a power function. Once again, they will give you the general form of it. We're trying to solve for a and b, given that it passes through the points 3, 2, and 6, 9. Now the steps are going to be exactly the same as when we wrote exponential equations. So the first step is to substitute x and y from each ordered pair into the function. So on our first one, x is going to be 3, and then y is going to be 2, and then our second point, 6 is going to be x, and 9 is going to be our y. So we're going to plug that into there. So we have 2 equals a times, this is where it changes, 3 to the b power. Our second equation is going to be 9 equals a times 6 to the b power. Now our second step, just like we did last time when we did exponential functions, we're going to solve for b by dividing the two equations. Now this time we're going to make sure that the equation with the bigger base is on top. Remember, x is actually our base this time. So if we look at the two equations that we have from number 1, we can see that the second equation with a base of 6 is bigger. So we're going to put that on top. So we're going to have 9 equals a times 6 to the b power, and then divide that by 2 equals a times 3 to the b power. Okay. So now what we're going to do is kind of simplify this. So we'll do 9 divided by 2. It's fine to get decimals here, which is probably very likely what's going to happen. So we're going to have 4.5 equals. Now the a should always cancel out because you're always solving for b first. Now look at here. We have 6 to the b power divided by 3 to the b. Notice that they now have both the same exponent but different bases. And this is where we're going to get back into our exponent rules. Remember, when we have different bases, let's just say a and b, and they're both taken to the same power, m, what happens is we can distribute this exponent to both our numerator and denominator when we're dividing, whenever it's different bases. So we have a to the m over b to the m. So this is the situation we have right now. We're just reversing it. So what we can do now is we can place 6 over 3, make it one fraction. And then both of them are being taken to the b power. Now that we have this, we can actually take what's inside the parentheses and divide it. So now we have 4.5 equals 2 to the b power, because we know 6 divided by 3 will give us 2. And then we keep the same exponent, which is in this case b. Now, what we're trying to do is get this b out of the exponent spot because we need to solve for it. This is why we did solving logarithms and exponentials before we did this. Because remember, to get this exponential out of, or this b out of the exponential place, what we're going to do is take log on both sides. So we're going to have log of 4.5 equals log of 2 to the b. Now, if you don't remember this, this is from our 7.6 day 1 notes when we solved exponentials. There were the two different ways, either get the bases to be the same. Well, we can't get 4.5 and 2 to be the same because they don't have anything in common. Or if they don't have anything in common, take the log on both sides. Once we've done that, now we're going to use the log property. We're going to take our exponent and we're going to place it in front. This is when we talked about condensing and expanding logarithms using the log properties. That is 7.5 notes. So notice how a lot of this information is kind of moving on to different types of problems. So make sure if you don't remember some of this information, you go back to those notes and really relook at it. Because if you don't understand those two sections, 7.5 and 7.6, then this is going to be way too hard to figure out. So you need to know those two sections before knowing this. Okay, now that we've done that, I now have log of 4.5 equals b times log of 2. Now we're trying to isolate our b, so what I'm going to do next is divide both sides by log of 2. And then once again, you probably will be getting decimals here, so that is okay to do. Divide this also by log of 2, because this cancels. And then we'll go ahead and round to 2 decimal places. So what you're going to do is plug this into your calculator. This is really using your change of base formula. So you're going to use log and then put 4.5. Now don't forget to close out your parentheses, because if you do not do that, it's going to give you a whole different answer. Then we're going to take log of 2 and then close those parentheses. Press enter. So that means our b value is about 2.17. Okay, so now that we've got our b, our next thing is to solve for a. So we're going to plug the answer for b back into either equation so you can solve for a. Once again, it doesn't matter which equation you plug it back into it, because you'll get the same a value, but you might want to use the one that might be easier to plug into. For that reason, I'm going to plug my b value back into the first equation we had. So 2 equals a times 3 to the b power. So here I have 2 equals our a value, which we're trying to solve for, and then times 3, and then I'm going to take it to the 2.17 power. Once I've done that, I'm going to go ahead and calculate 3 to the 2.17 power. And then once again, I'm just going to round to 2 decimal places, just make it nice and easy, basically following the same format. So we have 10.85, we can go with that, 10.85. Whoops, so yeah, 10.85, there we go. And because this is saying a times 10.85, remember to isolate our a, we're going to divide everything by that 10.85. So on this side it cancels. And so once again, you'll just do 2 divided by 10.85. And once again, we will just round to 2 decimal places, make it easier on ourselves. So we get about 0.18 as our a value. Now, once you have found your a and b value, you're not quite done, because our final idea is that we want to write an equation, in this case, a power function. So our last step is to plug both a and b back into the function, and then we leave x and y as they are. So our final answer here is we have y equals, our a value is 0.18 times x to the 2.17 power. So please don't forget this step, because that's the whole idea of what we're doing here. Okay, so our next thing that we're going to do is now use the regression feature. Now I'm going to kind of skip this problem, though it's probably on your notes. If you want to, you can try it out. I do have the filled in notes on Schoology, so you can check out to see if you got the correct answer. Okay, so let's now use a power regression. So here it says the table shows the typical wingspan x in feet, and then the typical weight y in pounds for several types of birds. And then here's your table. So they have, oops, I don't know what happened just there. But you basically have your x and then you have your y value. So we go down, scroll down. Part A says we're going to find a power model for the original data. So once again, it will ask you to either find an exponential or power model, but you do need to know the general form for that. I would use previous examples to kind of help you out, because like in example 1, they told you what that looks like. So remember, that was y equals a times x to the b power. Okay, so make sure you know the difference between your exponential and your power models. Okay. So now, using our graphing calculators, we're going to plug in those values. So remember, we go to Stat, and we want to edit. Now, sometimes you're already going to have values in for L1 and L2. If this occurs, all you have to do is you want to go all the way up and highlight your L1 or L2. You're going to press the clear button. Make sure it's the clear, because if you press delete, it deletes the entire list. And then I have to reset the calculator to do that. So press clear and then enter. And then I'm going to left arrow over and then highlight. And once again, I'll do clear, enter. So remember, we need to figure out our L1 and L2. So we go back to our table. Remember, L1 is always our X value, and L2 is always our Y values. So go ahead, we're going to plug in L1 and L2. So we're going to plug these values in for L1. When you do that, remember you plug in the number and then you press enter afterwards. And then we do the same thing. So we do 2.92, enter, and then so on. And then just kind of double check that these are the correct points that you have that's on your table, because even a slight change will give you a different equation. Okay, now we do the same thing for our L2. We plug these numbers into there. Oops, and I've noticed that I just put these all in L1s. Okay, make sure you put them in the L2. So I'm going to go ahead and delete these. There we go. Now I'm going to scroll over. Make sure you scroll over so you can plug these in there. There we go. So that's in L2. And 1.04, 1.69, 6.76. I think our last one is 16.03. There we go. Now, once you have done this, make sure that the numbers here match up with the numbers in your L2 and you have the same amount. Because even having one more in L2 or in L1, that will just kind of say an error once you try to find your regression. So make sure everything fits well. Once you've done that, then we're going to go ahead and go back to Stat. We're going to go over to Calc. Now we're going to go all the way down to actually the letter A, because this says our PWR reg, this is our power regression. So just make sure you go all the way down, and it's right underneath the exponential regression. Once again, press enter, and make sure your X list is as L1, Y list is L2. We're going to down arrow until calculate is highlighted and press enter. And once again, it should give you your A and B values here. So we're going to go ahead, let's on this one round to 3 decimal places, since in this case we have a 0 as one of ours in the 10th place. So that means our power is going to be y equals 0.044 times x to the 2.812 power. So let me scroll down so I have room to write that. So we said y equals 0.044 times x to the 2.87, I think it was 2. Let me go back and make sure that's correct. Yes. Okay. So that's going to be our power model. Now we look for part B. It says we're going to estimate the weight of a bird with a wingspan of 4.5. Notice that 4.5, our wingspan of feet, that was our x value. So we're going to plug that into x so we can solve for y. So we're going to have y equals 0.044. And then plug 4.5 in for x to the 2.872 power. And then we're going to go ahead and plug that into our calculators. And once again, you can either use the scientific or graphing. Both will work and get you to your answer. So we have 0.044 times 4.5 to the 2.872. And we have about, and we'll round once again to 3 decimal places since we did it here, we have about 3.307 pounds. So the weight of a bird with a wingspan of 4.5 is approximately 3.307. Please do not forget your label. If you don't know what it is, please go back to either the paragraph or the table, because sometimes they'll give you it. In this case, it's in pounds. And there we go. So remember, if you have any questions, email me, come in before or after school, or you can see some other math teachers if I'm not there. All of this is also on Schoology for the filled-in notes, so if you want to go back to those and look at that information, you can do that as well.